In this example, we want to determine the power of this current source and whether it's absorbed or generated. Now we don't know either the voltage or the current through that source, so we're kind of stuck. So I'm going to use conservation of power. We know the currents and the voltages across all of the other elements. So if we calculate the power absorbed or dissipated by each of those, add those all up, that has to be balanced by the power dissipated or absorbed by the current source. So to keep track of things, let's call this element 1, this will be element 2, and this will be element 3. The power of element 1 is P1. That's just the product of voltage and current for element 1. The current is 4 amps, the voltage is 3 volts, and this current is entering the positive voltage terminal. So the defined directions agree with the passive sign convention. Now you don't have to change the signs on the voltages of the currents. So this is 4 amps times 3 volts, and P1 is 12 watts. For element 2, I have a 1 amp current and a 1 volt difference, but this current is entering the negative voltage terminal. That's opposite to the passive sign convention, so I have to change the sign on one or the other of these. So if I redefine this voltage polarity to agree with this current direction, this is the positive, this is the negative terminal. I change the sign on the voltage, so this is minus 1 volt. So P2 is equal to 1 amp times negative 1 volt. This is negative 1 watt. So it's generating power. For this 2 volt source, P2 volt is the product of voltage and current. It's got 2 amps going into it. The voltage difference is specified by the fact that it's an ideal independent voltage source. And this current is entering the positive voltage terminal. So I don't need to redefine signs on anything. And this is 2 amps times 2 volts, which is positive 4 watts. That voltage source is actually absorbing power. Finally, for element 3, P3 is equal to 3 amps times 1 volt, but current is defined as entering the negative voltage terminal. We have to change that around. So I think I'll stick with my voltage polarity this time as being that, and let's change the current direction so that current is entering the positive voltage terminal. I've changed this direction, so I have to change the sign on the current. That becomes negative 3 amps. So P3 is negative 3 amps times positive 1 volt is equal to negative 3 watts. So the sum of the powers of all the elements in the circuit are the power from that current source, call that PIS, plus P1 plus P2 plus P3 plus P2 volt. And by conservation of power, that has to add up to be 0. So PIS plus P1, which is 12 watts, plus P2, which is negative 1 watt, plus P3, which is negative 3 watts, plus P2 volts, which is 4 watts, is equal to 0. Let's see, 12 watts plus 4 watts minus 4 watts is 12 watts. So PIS is equal to negative 12 watts. And the current source is generating 12 watts because that's negative.